Good afternoon students, welcome to JCE Connect channel. So today we are going to see the next part of Gauss law. So some of the mathematical representation of Gauss law are as below. If there are n number of point charges q1, q2 up to qn enclosed by a surface, then the total flux is equal to phi is equal to q is equal to q1 plus q2 plus qn, that is nothing but summation of qn. Then if there is a line charge, then the equation is phi is equal to q is equal to integration rho l into dl, where rho l is the line charge density. Then if there is a surface charge, then the flux is given by phi is equal to q is equal to surface integral, that is s into rho s into ds, where rho s is the surface charge density. Then if there is a volume charge, then the equation becomes phi is equal to q is equal to, that is total charge, integration the volume rho v into dv, where rho v is the volume charge density. So these are the some of the mathematical representations. So after studying all this, we'll just go through a simple problem based on the Gauss law. So the problem statement is the flux density D is given by R divided by 3 into AR nanocoulomb per meter square. This is the flux density is in the free surface. Then they have asked to find the E at R equal to 0.2 meters. Second one, find the total electric flux leaving the sphere at R equal to 0.2 meters. And third one is find the total charge within the sphere of R equal to 0.3 meter. So to begin with this, first we will solve the first one, E, that is the solution is, this is the solution. So to find E, we know the formula E is nothing but D divided by epsilon naught. So this D divided by epsilon naught is given, or we know this formula. Then what is D? D we can get from the problem statement, that is D is nothing but R divided by 3 into epsilon naught. This epsilon naught is substituted here, then this is AR. So what is R? R is nothing but 0.2, then into nanocoulomb 10 raised to minus 9 divided by 3 into epsilon naught value is 8.854 into 10 raised to minus 12. So the value answer we get is 7.595 AR. So E value, E unit is volts per meter. So this is the E value we got. This is the solution for A. Then B we need to find, that is total electric flux leaving the sphere at R equal to 0.2. So for second solution we have flux. Total flux is nothing but total charge. This is nothing but integration surface, that is D dot ds. This is the Gauss law formula. So what is ds? So we get ds it is nothing but what? This is a sphere. So sphere is nothing but r square into sin theta d theta d phi. This you know from the previous class. This is from previous classes. Okay. So what is d dot ds? This becomes what? So surface integral. It is in the sphere. So I have two integrations. That is integration for phi. Phi is equal to 0 to 2 phi. Then integration theta goes from 0 to pi. Then d is r divided by 3 into the value is r square sin theta d theta d phi. So this is nothing but what? Integration I will solve. That is r into r square is r cube by 3. Then d phi, integration d phi is nothing but phi 0 to 2 phi. Then integration of sin theta. Sin theta is into minus cos theta. That is minus cos theta 0 to pi. So if you solve this, you will get this phi is 2 pi. Then cos minus cos theta. If you substitute pi, this becomes plus 1. When you substitute this 0, it becomes plus 1. That is r cube by 3 into 2 pi into here. When I substitute pi here, this is cos pi is minus 1. Minus 1 plus 1 is minus 1 into minus. This is plus. Then cos 0 is 1. Minus of minus. So this is 4 by 3 pi into r cube. This is in terms of nano coulombs. This is q value. So, but they asked at point 2. So, at point 2, at 0.2 meters, q will be, if I substitute here in terms of r, that is 0.2, the value I am going to get as 33.51 picocoulombs. That is, or we can write it as 0.0335 nanocoulombs, or you can write it as 33.51 picocoulombs. Then they ask at point 3. So C will be at C at 0.3 meters. The Q will become, just substitute the value of R, that is 0.3. Then we get 0.113 nanocoulomb, or this you can write as 113.097 picocoulombs. So this is the answer. So one more problem we are going to solve, that is, this is the problem statement. Non-uniform surface charge density of R 5R R square plus 1 nanocoulomb per meter square lies in a plane z equal to 2 where R is less than 5 and rho s is 0 for R greater than 5. The diagram is shown here. This is the z plane, that is z equal to 2 plane. In that you are placing the one non-uniform surface charge density of this much 5R divided by R square plus 1 nanocoulomb per meter square lies. Then how much electric flux leaves the circular region R less than 5 in z equal to 2? This is the first question. So first we need to calculate the phi value. So what is phi? So first we need to calculate flux leaving the charged enclosed according to Gauss law. That is, first I will find phi. This is equal to charge is equal to, this is surface integral. So S, then rho s into ds. So it is nothing but what? Integration 0 phi is equal to 0 to 2 pi, then integration, one more quantity is r, is equal to 0 to phi value, because r is less than 5. So this is 5r divided by r square plus 1 into ds. ds is nothing but r dr into d phi. Okay, so this is the phi value we have calculated. Then so what this equation becomes? This is nothing but integration phi 0 to 2 pi integration r equal to 0 to 5 then 5 r square divided by r square plus 1 into dr into d phi. Okay, this is the phi value. So next, so from integration we have one rule, integration rule, that is x square into dx divided by a into x square plus c. This is nothing but x divided by a minus c divided by a into 1 divided by square root of AC into tan inverse x square root of a divided by c. This is the one standard integration rule. So if you apply the same rule here for phi is equal to or q is equal to integration phi is equal to 0 to 2 pi integration r equal to 0 to 5. This is 5 r square divided by r square plus 1 into d phi into dr. Anyway, you can write, no problem. So here phi is constant, I will take it as phi outside, then phi if we integration do it, it becomes phi equal to 0 to 2 pi. Then according to the formula, the remaining term is x by a. This is r in place of x, here we have r, this is r by a, this is nothing but r minus c is 1, a is 1, then inside the bracket, that is 1 divided by square root of AC. A and C are 1, that is A equal to C equal to 1. So the equation reduces to tan inverse R. Okay, tan inverse R. So this is 0 to 5. Okay, so this is nothing but 5 into 2 pi into 5 in bracket minus tan inverse 5. Okay, so when you substitute 0 here, 0 minus tan inverse of 0 is 0, so that term you can leave. Then this only you can substitute. Use calculator in radian mode, then we will get the answer. It as 113.932 nano coulombs. Okay, this is the answer for first question. Then for second, B, answer is, so anyway AZ is moving at the top, then minus AZ will move at the bottom. So half of AZ or incomplete AZ, some half part will move at the top, half part will move at the down. So we have the charge or flux which moves in AZ is 113.932 divided by 2. This is the nano coulomb. That value is, you will get it as 56.966 nano coulomb in minus AZ direction. Okay, this is the answer here. This is the answer. So rest we will see in the next class. Thank you.